Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn? In this session we are going to detect potholes of our road with the help of TensorFlow-lite on Raspberry OS Bullseye using Raspberry Pi 4. But before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, we are going to detect road potholes with the help of TensorFlow-lite using Raspberry OS Bullseye 64-bit version with Raspberry Pi 4. For that, first you need to install opencv latest version, which is 4.6.0, and TensorFlow-lite on Bullseye 64-bit version. I have already created a video how to install opencv and TensorFlow-lite. I will mention video link, watch video and install all these basic things. Okay, then for today's session I have created here a repository. The repository name is tf-lite rpi pothole. I will mention link, copy link and paste link inside the browser. Then go to the code, copy the link from here, and we are going to clone our repository. So open terminal, run the command git space clone space paste the link of our repository which we copy, and it will clone our repository. As you can see, it's cloning. So done, we have now our repository. So simple. What we are going to do, we are going to open our file manager, and inside file manager, as you can see, we have here our repository tf-lite rpi pothole. Just open it, and we have here images, okay, our data, and we have here video file for recognition. Okay, so we need to unzip these two zip files. Okay, so right click and click on extract here. It will extract our images folder. So inside this folder we have all images. Okay, as you can see, this is what our images for road potholes. Okay, as you can see, so we are going to draw a rectangle with the help of label EMG. Simple. So then we need our video file. So again, if I go back, so this is what our video file. So right click here, click on extract here, and as you can see, MP4. So this is what our video file. Now what we want to do, we want here our label EMG software. So this is the text file. Right click, open with text editor. Okay, and inside that I have mentioned the commands, okay, for installing label EMG. So this is the first command. With the help of this command we are going to install pyqt5. Okay, so open terminal and paste the first command, just hit enter. It will install pyqt5-dev tools on our Bullseye. So I have already installed. Then we need our label EMG. So second command, copy from text file, open terminal and paste the command inside our terminal, just hit enter. And as you can see, requirement is already satisfied because I have already installed label EMG. So this is how you need to install label EMG. Now we have done. Now what we are going to do, as I mentioned, we are going to train our data. So let's just close all these things, close text file, and we need our terminal. And here we are going to run our label EMG. So run the command like this way: sudo space label and LA. Just press LA from the keyboard and press tab button. Okay, as you can see, this is what the command label EMG. So LAB, if I press tab button, it will auto complete our command sudo label img, hit enter. It will open our label img. As you can see, this is what our label img software. So here we are going to first select our dir. So open dir, and we have our dir inside computer, then home, then pi, and then we have our folder which is tf-lite rpi pothole, and this is what our images folder, pothole images. If I click choose, and as you can see, this is what our images. Again, change save dir, same folder, computer here, then home, then pi, and then our folder which is tf-lite. Sorry, we need to go back, this one, tf-lite rpi pothole, and this is our images folder, pothole images folder. So simply we are going to select choose. So we select our open dir and we select our change save dir folder. Now here we need to select Pascal VOC, and then we are ready. We are going to create our rectangle box. So select create rectangle box, and we are going to draw the rectangle box on our potholes like this way. Simple. And here we are going to mention potholes. Okay, potholes. Click on OK, or you can mention road potholes. Okay, so then click on save, next image, and here again we are going to same way draw a rectangle on our potholes. Click on OK, save image, next image. So this is what our next image. Again we are going to draw a rectangle on potholes. Click on OK, click on save, next image. So this is how I am going to draw a rectangle box on our all images, and after that I am going to start again our video. So friends, we have done with drawing rectangle. As you can see, this is what our last image. Okay, we have here 70 images. If I go back, as you can see, I have draw a rectangle on potholes on our images. Okay, here also. Okay, so we have done with drawing rectangle. Now I am going to simply close the label EMG software. Now what we want to do, we want to create a new folder. So we are going to open a file manager, and inside our TF-lite RPi pothole, this is what our pothole images. Inside that we have our all images. Okay, image and their XML data, image and their XML data. Now what we want to do here in TF-lite pothole, which is our repository, here I am going to create a new folder. The folder name is freedom tech. You need to mention a same folder name. Okay, so create here a new folder and mention the name freedom tech. Okay, freedom tech. Click on OK. So inside that again we are going to create two new folders. So right now I am inside a freedom tech folder, and here we are going to create again two new folder, which is train and validate. So right click, new folder, train, click on OK, and then again new folder, validate. Okay, validate, simple, click on OK. So we have now two folder. Now what we want to do, we want to copy our all the data from our pothole images to our freedom tech train and freedom tech validate folder. So just we are going to press here Ctrl+A, then right click, copy, go back, freedom tech folder, train folder, just paste all the data, then again go back and validate folder, just paste all the data. That's it. So this is how you need to copy paste the data from our images folder, our pothole images folder, to our freedom tech train folder and freedom tech validate folder. Simple. Now we need to create a zip file, or we can say we need to create a zip format folder of our freedom tech. For that, what we are going to do, we are going to open our terminal, and here we are going to run the command. So first what we want to do, let me clear the screen. First we need to go inside our repository folder. So run the command like this way, cd space TF-lite, press the tab button, TF-lite RPi pothole, just hit enter. If I run here ls command, and here it is, as you can see we have our freedom tech folder. So here we need to run the command like this way, sudo space zip space -r, then we need to mention freedom tech, okay, freedom tech.zip. This is what our folder name, freedom tech.zip, and then mention again freedom tech. This is what our folder, okay, freedom tech, and /star. It will zip all the content which we have inside our freedom tech folder. Okay, then just hit enter. As you can see, we have zip our folder, and here it is freedom tech.zip. So now what we want to do, we want to move our freedom tech.zip on our Google Drive. So let's just open Google Drive. Okay, so this is what my Google Drive, and here we are going to right click, file, upload, then our folder which is TF RPi pothole. Okay, and here we have our freedom tech.zip. Click on open. Now it's uploading our file. So meanwhile what we are going to do, we are going to open our Google Colab for training. Okay, so Google Colab. So this is what our Google Colab. Here I am going to remove all my old sessions. So just click on recycle, click on yes, that's it. Now we are going to upload our Colab file. So click on upload, then click on choose file, and we need to go inside our same folder, go to the TF-lite RPi pothole, and this is what our Google Colab file, as you can see, IPYNB. So click on open. So it's now uploading our file. So friends, we have successfully uploaded our Google Colab file. Then go to the runtime, then change runtime type, select GPU, then click on save, then click on connect. So we have connected. Now we are ready and we are going to run our code one by one. So just scroll down. So first we are going to install our TF-Lite model maker and TF-Lite support. So click on here. It will run our first code. So done with first code. So just scroll down. Now we are going to import our required packages. So click on here. It will run our second code. Done. So just scroll down. Scroll down. Now we are going to import our Google Drive. We are going to mount our Google Drive. So just click on here. Now we need to give the permission. So connect to Google Drive. Then select your account. Then here scroll down, click on allow. Now we successfully allow our Google Colab to access our Google Drive. Done. As you can see, we have here our freedomtech.zip. Okay. So now we are going to unzip our freedomtech.zip. So click on our next code. It will unzip our all data. Done. So then scroll down. Then here we need to mention our class name. So we have here only one class and we need to mention here class name. So what we are going to do, we are going to open our file manager and our folder, which is TF-Lite RPipe pothole, and we have our Freedom Tech folder. Inside that train folder, and inside that we have our images and data. So we need to check our class name. So just click here. It will open our file like this way, the XML file, and here we mention our class name like this way, potholes. So same name we want to mention here, potholes. Okay, so just close, and where is our Chrome? Here. So here we are going to mention potholes. So this is what our class name. So remove, because we have here only one class, so we are going to mention only one class name. In single quote we are going to mention potholes. Here also same way, remove the second class because we have only one class, and here we are going to mention potholes. Simple. So click here. Done. Now just scroll down. Run our next code. Done. So now this code will be create our model. So here what we want to do, this will basically train our images. So here what we are going to do, we are going to increase our train rate. So simple, here it is 20, we are going to mention the iteration, we are going to mention, let's say 90. Okay, so from here you can change the iteration. So right now by default 20 is there, I have changed with 90. As you can see, 90. Okay, so now we are ready and we are going to start our code. And friends, as you can see, the iteration is started 1 by 90. So it will take some time. Meanwhile, I will pause video. So friends, our iteration process is completed. As you can see, 90 of 90. Now just scroll down and next code, evaluate the model with validation data. So just click on here, model evaluate. As you can see, we have done. So just scroll down. Now this will create our android.tf-lite custom model. So just click here. So friends, done, as you can see. And now if you click here, android.tf-lite, so we have our custom model ready. So now we are going to simply download our model. So just click here, click on download, and now it will download our android.tf-lite model. So friends, we have downloaded our model. So just click here, click on show in folder, and inside images, inside download, we have our model. Okay, so just cut okay, because we want to move our model inside our main folder. So just right click, cut, and go to the home, okay, then Py. And if you install TensorFlow-lite watching my video, then you have here TensorFlow-lite -bullseye folder. As you can see, TensorFlow-lite -bullseye. This is what the repository for installing TensorFlow-lite on Bullseye. So just click on the folder, then you will have examples folder, then light folder, then again examples, then we have here object detection folder, object detection, then Raspberry Pi. And here this is what our by default model. So here we need to paste our train model which we just create, android.tflite. As you can see, I have pasted. Simple. Now we are ready, and we are going to close all these things, and we are going to simply open our Thony Python IDE. So go menu, programming, Thony Python IDE, and we have our Thony Python IDE. So go to the file, click on open, then again go to the home, and we have our TensorFlow-lite Bullseye folder. As you can see, this is the folder. As I mentioned, this is the folder for installing TensorFlow-lite on our Raspberry OS Bullseye. If you follow my tutorial, then definitely you have TensorFlow-lite Bullseye folder. Okay, so just open the folder, then examples, then light, then examples, then we are going to search for object detection, then Raspberry Pi, and then detect.py. Click on OK. Okay, so we have opened our detect.py. So just scroll down, and what we want to do first, we need to mention the path of our video file which we want to run. So here on line 44, cap is equal to cv2.video capture camera id. This is the line for opening our camera, but right now we don't want our camera, we want our video file. So here what we are going to do, we are going to comment this line, okay, and again just copy this one line and just hit enter, and then just paste it, okay, and remove the camera id. And here what we want to do, we want to mention our video file path. So we have our video file inside our repository. So our repository which we clone tflite rpy pothole, and inside that we have our mp4 file pothole 1 mp4. So right click, copy path, and open our Thony Python IDE, and here we need to mention single quote and just press Ctrl+V. It will copy paste our video file path. As you can see, we have copy paste. That's it. So let's just save it, then scroll down, okay, and here what we want to do, after where we flip our frame, okay, here we need to mention resize. Basically we are going to resize our frame, okay. So here what we want to do, image is equal to cv2 dot resize, and inside that we are going to mention our image, and we need to mention width and height. So width 640 and height 480. Simple. Let's just save it. Now just scroll down, because we want to mention our new model which we trained, okay, android.tflite. So here as you can see, line number 118 default, this is the by default tflite model. So we want to change this model, so just copy this line, copy it, and just hit enter after that, and just paste as it is, paste. Simple. And we want to comment the by default model, so just mention here hash, okay. So we comment our by default model line, and here what we want to do, we want to mention android.tflite. So just remove this, and here we are going to mention android.tflite. Simple. So if I save the code and if I run the code, so ignore these lines, okay, this is not error. And as you can see, our frame is open and it's detecting the potholes of our road. Here it is, as you can see, this one. Now this one also. because we only train 70 images. Remember one thing, more images, then it will detect a perfect object. Okay, we have only 70 images, but the result is really good. As you can see here, it's detecting potholes, here also, here also. This one also is detecting. Again here, this one also is detecting. This one, as you can see, so friends, as you can see, we create our own custom model for detecting potholes of our road with the help of Raspberry Pi 4 on Raspbian OS Bullseye 64-bit version. Okay, so I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.